Awesome. So it's postable live. Right, so last stream, we were just working on trying to essentially spawn a bunch of spheres on top of a box. That's the basic idea. And we're trying to write scripts. There we go. So we have a few different material types. One is called the geometry material. So this takes like we're just rendering cubes here, right? And we're able to ray march into the cube and get this sort of brick surface with a custom geometry material, as it's called. So it's just a 3D material, basically all defined in code procedurally. And now we're trying to get these different types of materials called, which I'm calling geometry materials. And the idea is you can spawn a bunch of sphere volumes, or maybe we'll do box volumes. I don't know yet. We'll see. But sphere or box volumes that will spawn down, and you basically will be able to ray trace into those. And yeah, you would just be able to ray trace into those sphere volumes. Basically, that's the idea, and hit some other thing inside there. So it should be quite powerful, but we're just trying to set up the initial structure right now. And that is trying to place down these spheres on the surface. So we're just going through that at the moment. If you have any questions, feel free to ask away. Just going to start with a quick prayer, and then we'll get going. Right. Father in heaven, thank you, Lord, for this day. Thank you for doing all the work you do in our lives, both visible to us and both invisible to us. Thank you for providing everything that we have. Thank you for our partners and our children. Thank you for our family that's still alive. And thank you for the food you put on our table every day and the peace in our land. It helps have a good time today, a good stream today, a successful stream. You know, we get a good amount of stuff done, and the people watching as well have a good time. Maybe learn some things, and yeah, Father, we just pray that each and every one of these viewers that are watching, Lord, that you draw them in closer to you, Lord, and they get to know you, Christ Jesus, and that you are the way, the truth, the life. The only way to heaven, the only way to the Father is through you, Lord Jesus, and that atoning sacrifice on the cross. And yeah, just pray that any family members of the people watching who are sick or ill, we pray, Lord, that you send your healing over to them, Lord. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So essentially, we're spawning these spheres down on a grid. That's basically what's going on. See if I can keep this up. Graphics materials. And then, right, so, yep. Let's get Milton up. So essentially what we have is like we're ray tracing through a grid, and that grid can have like 4 spheres on it basically. That's what's going on. And we should be seeing them all over the... We're only seeing them on like the near side. We should be seeing them here and here, I think. Maybe. Oh no, but it is 0.6 in size for some reason. That might be the issue. Yeah, so where's Seldim? So when we printed this out, it was like, so that's 2, isn't it? 0.4. Hang on. Yeah, 0.4 in size. Let's make it 0.5 in size. And then maybe that sorts it out. No. Hmm. So, oh, that's still dim. So 0.2, so 0.25. Oh. Yeah, I think it's purely just because of the placement of the grid. Yeah, I think it might be okay the way we've done it then. Maybe though. But why are these partially drawn? That's the issue. It's part of the issue. So if we were to sort of like deduct 0.199. Hmm. Right, so we move this grid around a bit. Yeah. So the problem is we're getting sort of these half-drawn ones. And I don't know if they're sort of like inside the surface in any way. So I'm wondering if we can like peel it back. What's the way of doing it? So T is greater than this, then break. Yeah, so I wonder if we... Yeah, something is still very off. Okay, it's a little strange. Yeah, so... Yeah, I wonder if we should check if the grid is properly placed. Like, it should be centered. So the grid should be... So this is the volume. It should be starting from the center, right? And the grid will be going out like this, right? Okay, so... See, I wonder if we should... Yeah, so if the mouse is at here, um, So we can use the screen UV and debug screen UV. I think we can use that, or debug screen coordinate divided by. Yeah, so yeah, maybe it's something to do with negative. No, it won't be. Yeah, I wonder if we can do like a cell coordinate and print that out. Let's do that. So IVEC3 Alright, so let's print all these out. Cool, so let's park that one out the way. Alright, so we should be seeing a 1 and 2 to sort of start, and then as we go iterating through the grid cells, it's going to be repeating a bunch of 3, 4s, and 5s. So let's hold the mouse here near the edge, I guess. So alright, why is there a 6? The 6 is later in it. Oh, did it not recompile? I'll detail UV, that's what. Right, there's a ton of stuff that's printed out. Alright, I wonder if... Oh, there we go. Good, good, good. It was just scrolling. Okay, so 1 and 2s in the printer window are the start, and then it will repeat 3, 4, 5, 3, 4, 5 until you reach another 1 and 2. So the 3, 4, 5 are iterating through the grid cells. So the 4 is a... The 4 is a grid coordinate, is a cell coordinate. So it's, well, it seems like what it's doing is not actually going through. Yeah, it seems like it's not going through the coordinates 3 times the... Like, hopefully I can get there in time. No. But if you see... One, two, so 4... Yeah, so sometimes they repeat. I don't know if you can see it, but the coordinates in the G4 printout, before it prints out another G1 or 2, it repeats the same coordinates sometimes. So why would that be? So detail UV is number 3. the cell center has actually changed. Right, how can it have the same... How can it have... Yes, there's a slightly different Z value and X value, as if like the multiplying was happened a bit differently. Yes, I think we've got some... Yeah, this is interesting because the Z value is only changing. Oh no, sorry, it's the wrong one. 3 is the detail UV, right? So right, so 3. See, what might be nice is a way to debug draw some of this stuff, you know, but it's difficult. Like, we have ways to debug draw from shaders. We can do some of this stuff, but like we can't really move the camera too easily yet. We need to program that in, but we could say like have a line, but then if we move the camera, we would see it, wouldn't we? Maybe. Yeah, I think what we want to try and do, maybe we should set up some debug stuff. But the idea is we want to have a grid drawn on the screen, a line array going through it, and we want to see all the stepping points, right? All the hit points. So maybe the best thing to do would be yeah, maybe we can just write this all up in code and bring one of these grids, one of these things closer, and just have 2 points in space that it will do it down instead, and draw it maybe. Do it all from shader code maybe. Yeah, I think that'd be the best way to do it, because that way we can actually visually see what's going on rather than like looking at these numbers. Okay, I think that might be easier. We've just got to have ways of... So we can draw, we can say if the mouse is at something, this means it only gets called once, right? Then do some code. So we could have it emit some world space objects, and those do get drawn, I think. Like when we test it out. So draw 3D sphere. That's the thing in it, yeah. So position in world space, radius, color. So we did So we just probably want it to go 0 along the X, like 1 down the Y, and then probably a little bit forward. Some radius, we can do it as 1, maybe. And then color, let's just do -1 for white. And then Z test false. Yeah, great. So we do have debug drawing, right? Although white is for some reason black. I don't know why that is. Bizarre. So if we could do this, we could define like border thickness. Yeah, so it's, I don't know why it's black though. I don't think I've tested debug drawing since we did the refactor. Let's just see what's going on here. It might be to do with the shading itself. Hang on. Interesting. P3 from sRGB. Okay, so there's a simple bit of shading. Maybe it's something else to do with state. Right, so if I was to output vec4, vec3, 1, stay out for a sec. Output 2. It might be because of HDR. Yeah, so it's probably because it's due to HDR or whatever it is. Okay, so yeah, we probably need to have some kind of like, oh, there's a bit of ambient, right? So we just need more ambient line. So we need to be like, oh, plus, or is it multiply at that point? Oh, that clamps it. Hang on. We've got HDR buffer now. So why is that side? Right, let's give that a go. So we go back and we do a sphere instead. My whole reload broke. Cool. That's reasonable. Right, so we can do some debug drawing now. Wait, when is the debug drawing happening? So yeah, draw 3D. When is this happening? On the scene shaded image. Right. I remember now. So there'll be bloom, which still needs to happen, right? So bloom happens. And then you got the tone mapper. Yeah, it's then post-processing. Maybe we should make bloom happen first. Yeah, so we make bloom happen first. And then you do it on top of bloom. Then they won't have a... They won't be excessively bright. Because they're just debug shapes, right? But really it should probably happen after post-processing. Maybe? I don't know. Let's try it here. So bloom outputs to a what? The bloom, scene bloom image. Right, can we try that out? No, I got another problem. Scene bloom image is not compatible. Alright. Let's just not bother with that. Let's just live with that. So, right, so now let's do this thing where we... Right, so now all the debug shapes working. The plan is let's move this cube closer. Then we'll debug draw the grid around all of these shapes. I think would be a good idea. We could equally just get rid of the other ones for a minute. Yep, so let's go to graphics. Let's go to mesh cache alloc. So let's comment out the more, I guess. And we'll just put, yep. So what we can do is, I guess, we can just do an identity matrix here. In future, we could make it spin. Oh. Excuse me. Yeah, multiply there. Okay. Cool. So the X should be 0, obviously. Right, so what we plan on doing is drawing a... Alright, 0.25. And then 0.5. So what I plan on doing is drawing a grid in here. Maybe a little bit closer. And then we can draw 2 lines, symbolizing an array. And seeing all the intersection points. Maybe we should move the game. Let's see. Where's the grid? Oh, where's the camera? So it's not orbit cam. Yes, anything 185. Oh, that's right. We can just spin the camera. So we don't need to change the geometry, yeah. So we can just spin that when need be, which would be cool. Yeah, so we'll start with something basic like that. And we'll just do it in 2D essentially. And yeah, if we model the debug thing in 2D, yeah, so only draw one slice of it, then we can just basically rotate and yeah, just model in 2D. We don't need to rotate at that point, and we can configure the ray and move the ray around and see all the problems in 2D, and that should be fine for 3D. Okay, so nice, put it 0, lovely. Okay, so let's just start doing some debug stuff. Oh, why did my laptop die? Went to sleep. Cool. Alright, just leave this running. Now, let's go to the shaders. So when it comes to like, when we have the mouse on the screen, we're going to define a few things. Let's have a test array. So we'll call it test. So, hang on a minute. Where's the array? Yeah, so I guess with any of this code, we don't want it to do anything, actually. So we want to probably just comment this code out here so it never does anything. Cool. Right, so next thing we want to do is say, right, temporarily just remove all this stuff here. So ray origin. There's detail UV, isn't it? Alright, so what we could do is collect all the points. So we define initial array, collect all the hit points in material space, then at the end convert them back and debug draw it all out. Yes, so why don't we first start off with a debug draw in the grid. So it would just be one of these calls. And all right, so the idea would be you're going to have we just want to debug draw the grid. So there'll be for every yes, we need like an XY type of thing. So while so it'd be equal to negative yes, I think you just want to keep iterating it. Let's just start at 0. And while it's less than 1, I think. Something like that. We could probably store all the positions as well. And then X. So the basic idea would be you want to draw a cross, basically, I think. A cross section that goes from... So I think there is a debug draw ABB min-max. I think that's the thing. Yeah, good. So min-max border thickness. Oh, equally, you could just draw a bunch of grid cells with an inset border. I could equally do it. Yeah, so that would be... Your min would be... plus seldom, some of that, okay? So it'd be X... X, Y, and the Z will be something like 0. And then... plus seldom. Now, problem is this is going to be in material space and not world space, so we've got to change that. Let's just punch it in for now. So let's just say the world space be 0.01 thickness, some of that. Cool, so we do see a grid now, yeah? Right, so I have to have it on some pixels which are V8. So we're seeing it's going from, it's going a bit far. So the other thing as well is to get rid of the study debug sphere. Right, so the next thing to sort out would be to make a little quick function or maybe a macro, since I don't really want to move the code from too much of a, let's do a macro, we'll call it M, I guess, or Q, or T for transform maybe, it's a Q. Okay, so Q, and the idea with Q is that it will take some kind of position and then do like a matrix multiply thing. World from material. Mol P. I think that's all it would do. So we'll just wrap this in a queue. And this in a queue. And I think it didn't like it. Oh, it did. Huh. Why is it... Like, I understand why it starts from here. You know, I'm meant to repeat this line a few times, right, and do some negatives. I understand that. But why is it all up here? Oh, that's because it's too close to the screen because the Z. No. Because this is in... yeah, so what I'd like to do actually... Right, so the Z is 0. Maybe that's not helping. So let's change the Z. Yeah. Okay. Afforded a mole P. Oh, okay, so that's because the translation has not been set to anything. Lovely, okay. Right. So in this case, what we'd like to do is set world from material translation equal to something sensible. I don't know what that would be though. We can hard code it for now. Doesn't have to be perfect. So that would be, we had that like, oh, it's a 0, 0, 0. Hang on. Right, so if it says 0, 0, 0, that means we need to put it at... I'm confused now. Right, let's move this to more of a negative. Okay. Thing is, we can't Z test this either because I don't think the depth buffer is being filled with anything proper. Depth image, yeah. Wait, depth layer image, what about? Yeah, it's all uninitialized. If we populate this, then maybe it would work. So, could we do that? No, it's going to take some time. Hmm. What I could do is change the game camera. Let's get it to say rotate. Right, I think that's going to crash, but it's fine. So we get it to rotate and we can debug draw this and test that it stays aligned. Oh no, but it's going to keep rotating with the screen, isn't it? Oh no, this is good. Perfect. This can help us find where it is in 3D space. So it is actually in the middle. It's just a little bit too big scale-wise. Interestingly enough. Bizarre. Right, so... Like, if I made it such that it's 0.5, that's basically it. Right. Now, yeah, right. I don't know why that works, but it's going to be good enough for our... It might be because the size of the object or something like that. Anyway, let's just repeat this so it's... just negate the x here. Then negate the y. And voila. Well, sorry, these are meant to be minus then minus. Right. It's min max. The mins obviously need to go belong over to the mins. Well, cool. Alright, so here's our debug grid. It's pretty reasonable. Now, if we just line the camera up, it looks like it's moving, but yeah, if we keep it straight, it's because we've got a perspective camera as well. It doesn't really help, but there we go. So let's just go back to the game.c. Let's turn off the moving camera. So all we're going to do is place a ray, like coming from outside to the inside. I think maybe we can, rather than doing if is mouse at, what we're going to do instead is just say, right, if screen coordinate equal u vector 200 and do like an all. Not debug shading, I mean to say the can I say -1? So I'm trying to just get us to get the yeah, there's that. If all equal to 0. As an IVEC2. Still though. Hey there, Calja, welcome. How the heavens, eh? No, how the hells, yeah. Anyway, do you learn this? Your third year computer science student getting to see any tips other than do stuff? Yeah. So what you want to do, like graphics programming? Basically, is that the question? Like, so the thing is about programming is it's like you can do everything and anything with programming, basically, right? So it's a very, very, very big field. So if you want help specifically getting somewhere, then have to refine it a bit. But yeah, graphics, there's ways to get in. Instant graphics. But yeah, graphics programming is a bit terrible, to be honest. But sorry, it's amazing. It's amazing the stuff you can do with graphics programming. It's just graphics APIs, a bit terrible. Yeah, so basically, if you want to learn about graphics programming, what I recommend doing, because this is fun, you get some feedback right away, shader toy. So learn to make some shader toys. You know, you can learn all sorts through shader toy. People make all sorts of cool stuff. 3D things, 2D things, and it's basically about running code per pixel in the web browser. And there's all tons of different techniques and stuff that people do. But the guy who makes it, called Inigo Quilez, this guy, he has tons of articles about stuff. Just type IQ, Inigo Quilez into Google, and this is website iquilez.org. He's got tons of resources and articles to read about doing graphics programming. And this will allow you to get up and running and do stuff quick without having to learn about terrible graphics APIs. But you can use like sign distance fields and ray marching to do like cool stuff. Like that's what this guy does a lot. He typically does ray marching into things per pixel. Does lots of cool things. He does like whole scenes and stuff as well, which gets kind of crazy. But you can learn about lighting, you know, 3D lighting in shader toy, because people do shader toys for that. No. But yeah, you can make like a voxel ray tracer or something. I don't know. You can do all sorts of stuff. Someone even programmed like Minecraft in here for some reason. But yeah, that's even controllable. But it's at least to help get your feet wet in it, you know? But yeah, this all takes, you know, if you want the theory behind a lot of stuff, his articles here really help. And you can be inspired by other people's creations, basically, or go in and tweak them and learn that way. This is how I would get into graphics programming to get some visual feedback right away. The other thing you might want to, like, if you just want to do graphics algorithms, it's sometimes easier using a pre-made engine because you don't have to write the whole engine yourself just to do graphics, right? So this is why people use Unity or Unreal or Godot, but the problem is with those is they're quite big engines. So there's that as well. So I don't know about that route. I wouldn't go that route, but I know people do it. What's another thing? There's little libraries you can use like Socol or whatever. They're like single header libraries you can use. And the guy's even got like a website. Yeah, so he has examples here, and so basically it's like little single header libraries that you can use to make a little application or make a game with that people use, and it sits on top of all the new complicated rendering APIs and stuff. So you could use this to sort of get going, and again, there's tons of samples and things to help you get going. So yeah. Yes, of course I want to close you now. No worries. But yeah, we also have a Discord if you want to come and chat in the meantime and ask for some tips. So I'm trying to get it to just debug render on a single coordinate, but like why? If all are equal to that. I'm super confused. Why? Oh, of course. There's no shading down here because it hits the sky. Right. So that would then mean, so let's just put it at like 645, 450. All right. All equal IVEC to 645, 45. I'm just trying to get it to debug draw while my mouse is not on the screen, basically. That's the plan. Ta-da! Right, so now I don't have to keep the mouse over here. Right. Cool. Next step is we want to define an array going from here to here, and we also want to define a bunch of hit points, basically. So we're trying to... Yeah, so we want to define, like, spheres. Yeah, so array... We want to collect all of the spheres that it's going by. The ones that they hit. And... Yeah, so I think we can have the array. So let's just put the array going from... We just got to hard code it, right? So I think this is a size of 0.5. So we just said 0.5 to the negative 0.5. And then 0.5 up. That should be the top left. But if we said, I think maybe let's try that out. Maybe let's do 6 just to make it be a bit different. But if we take that coordinate, what are we doing with it? Yeah, we're trying to debug draw a sphere at that point. So detail UV. Yeah, so that needs to be vector 3 with a 0 on the Z. Okay, so 0.1 in size, I guess, -1. Cool. So there's our point. So yeah, so we want to have our start ray up here, go all the way through. So let's move the start ray a bit. Shading UV would be the entry point. Yeah, it kind of doesn't help a bit because of the field of view, the field of view. Oh. We could do something where we like divide by Z and squish it, and then yeah, we could do a thing where we divide by Z, squish it down. Oh yeah. Yeah, I think we should probably use the 2D functions. And then we haven't got this stupid Z thing going on. That'll probably be better. Although I'm not really sure about this Q thing. So what are we doing with Q now? So hang on a minute. So there's like a draw 2D space basically. So we want to draw it in normalized device coordinates. Maybe respecting the aspect ratio, that one. The aspects are where normalized device coordinates. Right. So if we get rid of that Q thing. Right. So that would then mean min-max depth. Min-max depth, thickness, color. Oh yeah, then knows Z test parameter. Come on. Oh, there's a Q somewhere. Yeah. There'll be a circle, won't it? Space. Position, radius, depth. Oh. .1, I guess. And depth. Circle. Oh, there's a border thickness on a circle as well. Lovely. Lovely. Interesting. Position, radius, depth, border thickness, color. So close. Right, so ignore the storage one because it's on GPU, don't have a pointer version. Space, position. Oh yeah, hang on a minute, I've got to do .xy. Radius, depth, border thickness, color. Ah, lovely. Alright, we're in 2D now. Ah, this should help. Right, so we are using white as well, so quickly going over to that draw 2D thing, I think we've got a similar sort of thing, we need like an exposure or something, because well, could be a bit brighter. I don't know, 8? There we go, I guess it's what we want. Cool, right, so this sphere looks a little bit off for some reason. Yeah, I think that's right, so no, I kinda don't. Oh, the detail UV gets moved, doesn't it? Oh, it gets moved and it hits. Amazing. So it is kind of doing a thing. That's cool. So what is the sort of start? So if we draw out the start UV, I don't know if the hot reload just went busted. No, yes, the hot reload went a bit weird. Happens sometimes. Right, so there's your -1. Okay, so change the radius a bit. That's where the point is. So I guess that's where the... Okay, so if we take these... Yeah, I think we can be okay with that. So we could say color red. Is that even a thing? Sorry, it's RGBA 8 red. Cool. So that red thing there, or we can do green maybe. That is your ray origin. Ta-da! So we then want a direction. So we can do one of these. So it'd be an arrow vector, I'll call it. So position, vector depth. So start UV. So there'd be a direction, so ray direction. So the direction, let's do classic diagonal. So normalize. So 1, 1, 1, 0. So that would then mean the vector would be ray direction detail material space dot xy multiplied by something kind of small. Right, so that would be vector depth, thickness, depth, thickness. Right, it's just going in the wrong way for some reason. Yeah, it's going up. That's fine. Yeah, so we've got an arrow now. Cool. Right, so that's the way the ray is going towards. Now, the question is, you see, maybe all we want is just the vector of the ray going to the other side. To an end UV maybe. Do we have support for lines? I don't really have support for a line. Just do a vector. Well, line is just a vector without the arrow tip, if you will. So yeah, we could just say end UV. Right, technically there is no end UV, but we'll just write one as an end UV. So yeah, okay, so be strange. Oh wait, the vector would be right, start UV take. That's why. Cool. Right, so now all we've got to do is just collect all the spheres that will be randomly placed and down and get in all those hit positions basically. So Probably get rid of that. The thickness could come down. Right, so there's our lovely array. Nice. Right, so we go through and hit all these spheres basically. So we've changed the ray direction and that, so it should be doing it. So we could collect an array of these guys. So collect an array of spheres. You've only got like a 2x2 cell, isn't it? Of these things. Yeah, what do we really want to do? We want to say, if we make a structure, we can be like, oh, we've got a sphere here, 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 and whether you hit it or not, right? It's probably what you want. Can you put structures inside functions? I don't usually like doing this, but you know what, let's just do arrays. So we'll do a define of this sort of maximum number of spheres, if you will. We'll call it NN, so that would be called, let's say just do 64. So, wait, how many have we got? We've got a 4x4 grid, right? So 4x4 is obviously 16 times by 4 is 64, right? Is that right? Yeah, cool. So that works out, right? So we'll just call it spheres, the vec3, sphere positions. So NN, right, so that'll be so you also probably want to have some kind of radius. The radius is, and you probably also want to have the whether you hit or not. So array of Boolean. Yeah. So that's all we're going to do. So be something like sphere. Positions. We can do like a sphere index. So that'd be sphere center position. Yep. Then the radius is. Then the. What are we doing? Whether you hit. So starts off at false, ends up at true. Now, all we need to do is just do another lovely for loop. Over the number of spheres and simply render them out. So P radius is R and the hit. Right, so that's B hits. Lovely. So effectively, we always want to draw a sphere. Sorry, circle. And we can do the position, P. we can do a radius r. We can do depth, and then the size of the infinity f32. And here we're going to make it either red. We could do blue. What do we even do? Red for hip. But the red would be kind of like the red of the, like the orange, wouldn't it? Really, it's not going to be very nice. What colors we got? So yeah, we could probably do like right, we could probably do a sort of a grey maybe, I don't know. I got a grey background. Let's just try black, see how that looks. Hang on a minute. Position, radius, depth, thickness. Okay, so they're incredibly... Oh, it's because we stop early. Oh, very nice. Yeah, so bit of a problem. Not too much of a problem though. So the issue is we end up hitting these guys. Sorry, we end up missing them and then hitting the surface. Like the surface is defined somewhere along here, so what we could do is say, well, yeah, we've got to take out the surface check for a minute, because the surface check is going to stop us from going through the whole thing. Right. Oh. So this is kind of cool. We're getting some visuals here. I don't see... Right, maybe we get a hit. So let's just say H and then it makes it red or something. I don't know. Right, I don't see any change. So obviously there's no hit. What else could be making it leave early? Is it this thing? Right, not that thing. This thing? Right, so if the bar is behind. Why did I do that? So if it's a complete miss. Oh yeah. So we're meant to be ray tracing through and hitting the boxes as well. Yeah, I see what's going on. So we're trying to step through these boxes. So we've stepped through and hit this one, and then we've gone to step through again. But because we've not done a perfect diagonal, it's created a problem, right? So what you can see is if we were to change the Y, right? Get this. If we were to change the Y, let me do So y, so call it yy equals g sine g GPU time. So this would be -1 to 1, and if we just times it by 0.5, that'll get us. Sorry, if we did take 0.5. Hang on a minute. No. It times 0.5 plus 0.5. And then we negate it on the end UV. Cool. Cool. So great. It's going a little bit too fast, so we just want to slow down the time. So yeah, it's clearly not getting what we want exactly. So there's some big problems, and also we're stepping directly down the middle still. So what I would want to do is probably offset the y. Yep. So there are some bugs when we'll go directly through the corners when we're stepping through things. But for now, let's just get the debug drawing working perfectly, where it should be debug drawing all the spheres that will be in here, in each of these cells. Now, now this is how I should have written it first. Just debug drawing it. Doing way better. Cool, this is great. So we're seeing lots of problems, I think. So first of all, let's just try and get it going across the X or something dumb like that. Like, let's try and just be like, right, -5, 0.5, and then we'll do like, make it the same, yeah? Right, I think we lost it a bit. Yeah, so... Oh, there's a bit of a problem calculating the bounding box, I think. On the vectors. That's not very nice. So apparently the vectors have to be kind of... Alright, there's a bug. So we draw these using vertex shaders and stuff. So when it's a vector... Oh, didn't I already solve this problem? We basically compute a bounding box, right? What's happening? So draw 3D. What does the vector do there? I had to fix it, didn't I? Yeah, this is our boy. Right, past Henry has got us here, I think. Yeah, so you want to do a... We need the thickness as well to be decoded. That is a good point. Right, so draw 2D. Right, so let's decode the thickness word. Right, so we calculate this thing called P. P is the position. Right, so pos space is P. So let's get rid of that then. Right, so we just times the thickness by 4 for some reason. I forget why that is. Hang on, so that'd be a vec. Maybe it's just so it's large enough. No specific reason. Oh, because there's a times by 4 here, I think. I don't know. Anyway, we'll see. So we get the half vector, and then we offset the position such that we've got a center position coordinate. Then we basically, from the center, we're saying the position in screen space is position plus the absolute of half vector times by the signed norm, right, plus thickness. And that should do it. Come on. Work with me. There we go. I made the... Yeah, it needs to be times 4 because of the cone thickness, something like that. Lovely. So that makes the correct bounding box around the vector. Cool. So what we see from this vector now is we see there's some more shapes being drawn here, and it's not going through all of them. But there seems to be like, so there should only be 4 per cell, but there actually ends up being more. That's also very interesting. So yeah, it's kind of interesting. So what we want to tell is probably what cells do we hit and where do we hit them? So it might be a good idea to traverse. So we could store. Well, we don't know what cell we are here. We could hard code it so we know. So we could color it. We could color them red or something, and then all the hit positions. Can output those. Yeah. Yeah, I think glowing them, yeah, turning them red would be enough. Because what that would tell, yeah, turn them red should be enough. And then knowing, yeah, because basically, say if you did a diagonal, and you want to know, you probably want to make sure you've checked this cell, and that cell. So just glowing them red would be enough. But the problem is you want to make sure you don't hit the same one multiple times. So that's another problem, right? So you want to have a different color to know if you've hit them multiple times. So we can make that like a magenta or something. Yeah. So we'll just make a bit set. So 4x4 is all we need, so 16 bits. We'll say something like grid hit 2, right? 2 or more times. So basically, we've got the cell coordinate right here. Bam. Now, all we want to do is So we want to calculate a sort of a cell CI, we can call it, because we've already got cell I up there. So CI would be so your CI would be, you just flatten it, right? So cell coordinate, let's add 2. And then flatten it. So you want to do like a, can I do like a flatten 2D? You must have a vector 2 version of those, right? Didn't you? Yeah, you vector 2, yeah. So flatten 2D, and then the width would be a 4, yeah. So so we can say grid hit or equal CI 1 shift left CI. Then if grid hit and 1 shift left CI, then we grid hit 2. We or onto the grid hit 2, yeah? So all we need to do now is read it out here, and we can color it. We can get a color. Although, yeah, so really I should redo this grid thing. So we should just do 4x4 and do it based on cell dim size. With an offset of like 0.5 or something like that. No, yeah, with an offset of cell dim times 2, something like that. Okay, so grid start. So that'll be something like that. Make these four. Cool. So you now want to produce what's probably known as a cell start. That'll just be vec2 x, y times cell dim. Then the end is going to be +1 basically. Yeah. Get rid of both of these, I think. Then so it's grid start plus, yep. So nearly there. Cell start, cell end. Then the color. If you've hit grid, so we want to get the grid flat, the flat index, if you will, so call it the CI. So that'll be one of them. So effectively, if... Right, you gotta cast this into Boolean, isn't it? Because GLSL doesn't like it. But yes, if something like this, right? Then, excuse me. So, if you land in the grid hit 2, we want magenta. Else, if you land in grid hit 1, wait, color magenta. Then we have, oh sorry, it's RGBA. Cool. Else, do you hit the grid? Then we want color red. Else, we just do a white. Good. So, apparently... that compiled? Struggle to believe we didn't make some mistake. Yeah, alright, it's not reloading. Cool. So... got a vec2 that. And then that should be it. Right. Perfect. Can you see the problem already? So we've got the red hit, but we've got magenta. So magenta means we've landed in this one twice. It's not good. So another thing I wanted to change really is we should probably make these not be on the grid. Because that could cause some other problems. We can look at that later, but... Okay, so this is a big issue. It's magenta and that's bad. So you can see it's kind of going downwards because of some other reason as well. But yeah, so... Alright, what else we got? So... why is it causing a double hit? That's a pretty reasonable question to ask. They're all going to be the same really, so we could debug print. It's on a single coordinate, but so we're trying to... we want to know... yes, so I think what we would like to do... we'll just make a guard. Call it PP. Right. So we need a print scope. Where do we need one? Yeah, so actually we want a print scope here. We want to say like, you know, print one. Yeah, let's just print out a value. This just symbolizes a new frame. Separate in the terminal. We kind of want to see like, you know, yeah, I think it would have got minus value basically. I think that's what's going on. But yeah, so we want to essentially see a cell center position. So detail UV. The cell center position. All right. Cool. So we're seeing the detail UV being minus 0.5 here, and center positions here. So it does step through. It does a whole bunch of times. Where's the... So we look out for the threes. Now, so it did move from one to the next. But then it didn't move on the next one. But it did on the one after, but it kind of moved. Huh. Said it moved down. Some as well. That's not very nice. Yeah, it's very bizarre. Right, let's print also out the cell coordinate. Right, so a big help. So you got -2, -2, then it goes across 1. Really, we should probably just add 2 to this to make it look sensible. Right, 0, 0, so bottom left is 0, yeah? So 1 across, and then it doesn't do any across, and then it goes down by 1. Right, so we're seeing that here, right? So it's matching up. But what's going on? So detail UV is 3. It seems like the detail UV has moved by some amount. It just didn't probably move enough. Yeah, maybe they're not aligned properly, maybe. What is the, can I print out the, what would you call the cell dim? Right, so the cell dim is 0.4. So, if your cell dim... Yeah, so it seems like that's right on the border, and if I nudge that just a smudge, I think that's the issue. I think it's what's going on. Because wait, hang on a minute. It's saying that the center is is minus 0.2. Surely that's not right. Yeah, something's a little bit off. Yeah. Yeah, so what's happening is it's not center aligned correctly, I think, because it's saying, oh no, it's a center position. Yeah, that's right. So, that is right. Yeah, but why did you ray trace directly up to the 0 point? This ray trace from 0.5 to 4. And the border would be 0.2. Yeah, I think this is wrong. Should be a full dim, I think. But then why? I had the caps lock on, that's why. Whoops. So when a ray traces against here. It went down by 1 as well, that's not very nice. Not sure how it got that value there. Let's try to do one down here though. But yeah, so it went from... I thought it would be a half dims though, like, I'm not sure what's going on. Because N... Interesting, you could pre-compute those if you... Right, that'd be fun. Right, that line bounding boxes, maybe that could work. Yeah, that'll probably avoid all those little issues where... Yeah, that could avoid those little issues where you need to nudge it by a bit to move the point. Yeah, cool. So... Right, so detail UV comes in here. Now... This is probably a very terrible name. Let's change it up a bit. So, what we probably want is something known as a ray origin. Now, the problem is we're stepping the ray origin and it's not very nice. So we probably also want another one to be known as like a um yeah, so we shouldn't need to nudge it anymore. I'm not sure about exiting the grid though. Yeah, so if your T is greater than 1 maybe at that point. Or 2, whatever it is, I don't know. Break. Right, so right, so this detail UV, you need to be able to compute some kind of like sample position. So that would just be ray origin, detail space, plus ray direction, detail space, times by T. And that's all that will be. So this will still be ray origin ds. Okay, so when we get a T hit back here a T, so that will be, it no longer has to do that. Yep. So box hit. So if it goes backwards break, we probably can get rid of that at some point, hopefully. It should never go behind. Anyway. That's the far, right? So all we're looking at doing now is making T become whatever box hit far is. Yeah, we need to get rid of this at some point. Okay, cool. Right, so this has changed it such that they're all squished into here now, and we've got multiple hits into there. So something weird's going on. What we're seeing is we're just clearly not advancing anywhere. Yeah, so we're clearly not advancing anywhere for some reason. Right, let's read these numbers. Numbers tell me. Right, so these numbers are saying, so 0. Yeah, so the 1 tells us the start is starting. So It seems like it went across the X by 1. Like, positive 1, right? And the Y as well for some reason. But then after that, it just gets stuck. Yeah, I think it could be that box. Oh, crap. I think it could be that box hit thing. It's not. It's sort of working when we do that. I don't know. Right, we're pretty close. Just gotta find. Oh, they're all scrunched up in here now. So redirection, ray origin. Let's look at these guys. All right, 0. Hmm. I wonder if we've got to nudge it. Yeah, it might be because it needs a nudge. Yeah, so it's not on the bound. Basically, when we hit this box here, we want to make sure we just nudge it a little bit over such this actually inside the next box. That's the basic idea. Yeah. Right. Let's check the printouts. Why is it? So 1 is when it resets, and now it's going through the grid. So it goes along the X, X, now along the Y for some reason. Wait. Well, the Y is moving for some reason. Although, oh, it's because the redirections. Right, my redirection isn't aligned with my. Cool. All right. Okay, that seems pretty reasonable. Now, let's try and where's ray direction? Yeah, so really what we should have done is done an NDV take start UV. Yeah. Now, if we reintroduce this moving one back, does it work? Hang on a minute. Doesn't seem to like what I've done. Cool. Lovely. Does this work? I think it might be exiting early because of the... Right, let's reduce it down a bit. Make it move a few places, okay? So I think I did a travel distance of 1 or something like that, but then... yeah, this is weird. Yeah, when it's going horizontal, like it does it all right. You can see it looks nice. But then the more diagonal it's going, it's like it's doing less for some reason. Is it because we hit this break here? Right, so there's a different problem. Basically, it's a different problem. We're not seeing any hits on the spheres either, which is a bit weird. But that's okay. We can look at that later. Why does the other sphere show up but the other one doesn't? Bizarre. Is it because there's like a hit thing? Is it something to do with the hit? Color red? No. Can't be, can it? Nope. Not to do with that at all. Yeah, a few weird problems. Very strange. So let's keep it diagonal for a minute and be... thinking about what causes it to exit. So we can just call the y 0.5. Right, so let's make it an obvious restart. So let's say 0. We see a 0 there, that just means it's a new frame. So we're seeing it traverse sort of down here, right, by 1. Then to the right, so we're seeing it color, right, so that's cool. And then it's saying also after it stops, right? Why? Why, oh why? Does it want to break? Is it this? Did we get a hit? Okay, so apparently we got a hit. So we want to comment out the facts it's doing hits. Because what hits are doing are causing... Right, so that's a clear hit, isn't it? So why isn't that showing up red? That is the question. Ah, so that's the reason why they weren't all drawing. Nice. Good, good, good. So we got a hit. So... Oh, right. Okay, that's the problem. Oh, yeah. It's amazing. But yeah, why isn't that a hit as well? It's fishy. But yeah, we can... So yeah, a bit weird some of this, but it's getting there. Is it this? Okay, cool, cool, cool. So, yeah. How could we know if, how could you know if you've gone too far in... How could you know if you've gone too far? Well, you typically would hit something. But I think you could say is the cell out of bounds. You could say, is the cell coordinate? So if any greater than ABS is that even a thing? Greater than equal, okay. So that would be known as a what exactly? That would be a so the maximum number of cells would be so if your cell dim is 0 point or is 1, you fit is 2 by 2, isn't it? So yeah, 1 divided by 2 would be 2. Seal, that's it, yeah, seal. So max So we grid dim, you call it. Cool. Hang on a minute. So it's 0.4. So 2 divided by 0.4. 5. It's not right, is it? Yes, I reckon a bit bizarre actually. If you sold in with 0.4, why is it not a 5 by 5? Why is it 4 by 4? Um, hmm. Right, so 1 divided by 0.4, 2.5. But it would be a floor, wouldn't it, at that point? So yeah, floor times 2, I think. So the number would actually be 1 divided by the half dim, if you will. Floor that times by 2. Right, I think that's the same result, to be honest. I think... Oh, no, it's a different result. That's a different result. I think the hotcode reload didn't want to work. Right, that's interesting. Why is that being shaded? Probably other reasons. Oh, wait. So greater than 2. Yeah, because this would be minus 2 to 2, wouldn't it, at this point? Right, let's hard code this for a minute. So 2. If any of them are greater. Yeah, so I think the problem is I started on the Z, didn't I? Where is it at? Nope. We ABS'd it, didn't we? Right, let's do another print. I already got printers here. Let's get rid of the +2. Alright, so -2, see it's ABS, right? If any of them are greater than... Wait a minute, this is what we want. 3. Yeah, so it's cell +1, I think. What number is this? Hang on. 10. Why is it 10? Yeah, 1 divided by 0.2. Right, is the wrong variable. Perfect. Cool, that's very nice. Right, so what are ending at the right place now? So what are ending at the right cell? That's very good. Cool. So, what we're seeing is it's going through this grid, and there's a bunch of spheres being spawned in this grid, right? And they're kind of been offset, and they're kind of randomized. So we're also seeing the hits where it's hitting, but it should be hitting these guys. I don't know why that isn't happening. And there's some other slight problems as well, I think. Yeah, ideally we would want to not have spheres inside other spheres. We probably want them evenly spaced out, different, you know. I don't know how we'll do that. We'll need to find a way of like picking 4 spheres and kind of pushing them apart maybe to be inside the area. Or maybe just have one inside the grid cell, right? That's the other way of doing it. But then you've... Yeah. Hmm. Hmm. Yeah, I wonder if we could do something a bit different. Rather than going through a grid, you still have a grid, but you just have one object inside the grid. And that way you don't have to keep stepping. You still might have to step through the grid though. Yeah. Cool. Well, it's stuff to think about. I like where this is going at least. So we're now debugging it this way rather than doing it through a bunch of printing. So it's quite good. So here's us moving the ray. Oh, we had some bugs there. We saw a magenta color. Magenta means it's stepping twice into the same grid cell, which is extremely bad. And that might be because of this guy here. Okay. But yeah, so we want to see all this logic working right. But it's getting there. Nice. Cool. Right, stuff to think about for next time. So I'm hoping to be on tomorrow from 2 p.m. GMT +1. We'll carry on with this for a few hours. Maybe I'll get some different ideas. But yeah, we want to try and figure out like how to place these spheres inside the grid nicely, probably separated, or maybe we'll think about different ways of placing a bunch of boxes and you ray trace over those boxes. I don't know yet. But yeah, stuff to think about. But in the meantime, guys, there's Discord if you come and chat, and there's also a way to support the channel if you guys want to support the stream. You can get access to the code to run on your own local machine as well. But yeah, so next stream Friday. Check the schedule down below, and yeah, that'll be it. Right, have a good night, guys. God bless you all, and hopefully I'll see you tomorrow. Right, catch you later.